Okay, this is Math 10 A&W with Mr. Sandhu. We are in chapter 3.2. We're on page 146 of your Mathworks 10 workbook, and this is example 2. A canning factory wants to use as little metal as possible to make cans. It considers 2 cans that each hold about the same amount. One is 4.5 inches tall with a radius of 4.2 inches. Another is 9.6 inches tall with a radius of 2.8 inches. Which can should they use and why? So, I guess they're saying that these two containers do hold the same amount of food. It's just a matter of which one of these 2 containers actually uses less metal to make it. Okay? And that's what I like about this question, is that it shows that volume is different than surface area, and it shows that you can have the same volume in 2 containers but have totally different surface areas, right? So let's look at a strategy first. The strategy here is going to be that you're going to have to calculate the surface area of both cans and then just see which one's bigger and which one's smaller. So it's really just 2 questions in one. This is a question of using a formula, plugging in the numbers, crunching the numbers down, and getting an answer. That's all this is. And when you look at the solution for this, this first part of the solution is saying, let's just find the area of the top of the can. Okay? And then, of course, because there's a top and a bottom and it's the same size, let's just double that amount and put that in the pot. Then let's find how much the area that wraps around the can is and put that in the pot. And then we'll look in the pot and see what our total is. That's one way to do it. Another way to, so that's doing it sequenced in steps, right? So the other way to do it would be to use the whole entire formula for the cylinder. We have on our sheet, our formula sheet, a formula that says the surface area of a cylinder. It should be there. So on my second page here, okay, it shows a cylinder, and it has something that says surface area of a cylinder, okay? It has a complete formula that says surface area equals 2 pi r squared plus 2 pi rh. Like if you want to do it all in one shot quickly, you could use the formula. It's fine. Or you could just find each part separate and total it up. I think I will do each part separately. So I'm going to start this question by finding the surface area of this top here. Okay? So what we'll do is use the formula to find the area of a circle. So on our sheet we have that. We have area, and I'm just going to put a little circle here. Area of a circle is pi r squared. Okay? So you take pi times the square of the radius. Let's plug numbers in. That means the area in this case is pi times the radius, 4.2 inches, squared. This is me showing all my work, okay? So I'm going to square the 4.2. So it's going to be pi times, so 4.2 times 4.2. A lot of people multiply it by 2. Don't do that. Remember, you're squaring it by itself. So 17.64, which means, notice I didn't do 3.14. What's going to happen when I'm done this question is I'm going to get it wrong, according to the book. The book, this whole workbook is going to use 3.14 for pi, and I don't like doing that. It's not as accurate. I'm going to use the pi button instead. That's why I haven't put a 3.14 down yet. I just left a pi symbol. Sure you can. If you want to use 3.14, if you're finding that that works better for you, do it. But just understand, like, what's going to happen on a provincial exam. For example, you do a multiple choice question on a provincial exam. You use 3.14. Then you look at the choices A, B, C, D, and you can't find an answer that matches. Okay? It might be frustrating for you. And you got to also remember that anytime you're multiplying let's just say instead of the full number pi, you use 3.14. If you then multiply that by a bunch of other things, then you've also multiplied the error, right? You've got a small little error that you've cut off by taking 3.14. But if you multiply that by 10, 1,000, whatever, then you're making your error 10 times or 1,000 times bigger. So you go to look at your questions and you're like A, B, C, or D, they're all way off. You might think, I don't know what I'm doing here, okay? So just remember that. Yes? You know, I can't say that for sure. I cannot say that for sure on a provincial exam because I don't write them, right? But my suspicion is yes. On a provincial exam, use the pi button. Okay? All right. So carrying on here, let's do this. What is pi times 1764? Bring up my calculator, and I will go 17.64, and I'll times it by, and I will hit the pi button, equals. So 55.41769. I have told you guys to try to keep a bunch of the decimals along for the ride until the very end. So don't turn around and put a 55 now. Keep some of the decimals. So 55 point, let's put 3 decimals in, 4176. So I'll just say 418. The more decimals you trail, the more accurate your number is. Okay. All right. So we know that that is the area of the top. So I'm going to write that down. Area of this top equals 55.418. I just used a formula, crunched the numbers, there it is. Now we also know that the area of the bottom is also going to be 55.418. Go ahead. So we can put this into the pot and we can double it as well, right? So I'm going to take I'm going to find the wraparound first. Is it for me? Okay, I'm going to pause this video. We have found the area of the top. We have found the area of the bottom. It's really easy. Use area of a circle formula. Now let's find the area of the wraparound. So basically what we're going to do is, if you were to take this wraparound piece that goes around that circle and you were to flatten it out, you're going to get something like this. You're going to get a long rectangle. If you took that label or that side off the can and flattened it, it's really a rectangle. We know that the height of the rectangle is 4.5 because it's shown right here. But what we don't know is how long this distance is. However, this distance is what wraps all the way around to there. So essentially, if we find the circumference of the circle, we also find the distance of this rectangle. And then we'll be able to find the area really easily. So let's use the circumference formula to find that edge here. Okay, this is the circumference right here, C. So the circumference formula would say circumference of a circle is pi times the diameter. All right, you can also use the circumference is 2 times pi times the radius. Those are the same formulas. It's essentially saying it's either pi times the diameter or it's pi times 2 radiuses. So that's the same thing. I don't care which one you use. Okay, I'm going to use the bottom one because we don't have a diameter in the picture, we have a radius. So let's just use this one here, and let's not use that one. So, but they say the same thing essentially. Okay, circumference is 2 times pi times radius, which is the same as 2 times pi times a radius of 4.2. Let's go ahead and punch that all into a calculator. So 2 times pi times 4.2 is 26.389. Okay, there it is. So we know that this circumference that goes all the way around here matches this long edge, 26.389. So we now know that we can find the area of this. It's simply multiply the length times the width. So multiply 4.5 times 2.6389. So I'll take that amount and times it by 4.5, and I have 118.752. 118. Okay, so we know that the area of this entire wraparound that happens, I'll just draw like a little dot here and say that that area is 118.752. Okay, so let's just take a look at what's going into the pot to find our total surface area. Our total surface area is going to be this guy here, which is the top, and 2 of them, because there's also the bottom, and then also this wraparound that goes all the way around the outside of the can, which is here. So that's what's going into the pot. So I'm going to total up 55.418, another 55.418, and a 118.752. I'm going to total all that up. So add the 55.418 and another one. And my grand total is 229.588. Okay. Basically, that is what this whole thing is. So I'm just going to put something on here and just say area, surface area now, total area of all sides is 229.588, and this is inches, and they are square inches. Okay? Now, that's not what the question is asking. The question is asking which one of these cans uses less metal, essentially. Which can would you use? How am I going to get to that answer? Just do it again, right? It's a lot of work just to find this answer, but that's where we're at. We need to do what I just did completely over again. So here's what I'm going to ask you to do. I'm going to ask you guys to find the surface area of that second can. You're going to have to find the surface area of the top, and also remember that that's the same as the bottom, and then you're going to have to find the surface area of the entire part that wraps around, total it all up, and see how much metal that is, and compare the two. Okay? So you guys go ahead and find that.